you. So this question is fourth question for AP Physics Free Response Questions 2024. So let's see what's there in the question. And the question says that a simple pendulum consists of small sphere that hangs from a string with negligible mass like this. The figure is there. So there is a small sphere. The top end of the string is fixed. The sphere is pulled to point A so that the string makes an angle theta with the vertical as shown. The sphere is then released from rest and swings through its lowest point B. So this is the lowest point B. The work done on the sphere by Earth between point A and B is WE. So the work done by Earth on the sphere. The pendulum is taken to planet X, so some another planet. The mass of planet X is same as mass of Earth, but the radius of planet X is greater than the radius of Earth. The sphere is again brought to point A, displaced theta from the vertical, released from the rest and swings through its lowest point at point B. Work done on the sphere by planet X between A and B is Wx. So one work is We, other work is Wx. Like on Earth it is We, on the planet X it is Wx. Justify why Wx is less than We. So we have to tell that why it is less. So first of all, see that what is work done. So at one point this ball is here and it goes like this. It moves like this. So we can say that this is the mg, the force, and that's the distance that has been traveled by the body. Just wait. Okay. So that's the distance h. So the work done here is mgh because the potential energy change is mgh. So when we are talking of two planets, that is one is Earth and another planet which has bigger radius but similar mass, that is planet X. So the value of G is, that is Gm by R square. So if the mass is same but the radius is increasing, the gravitation will be less. If Gx is lower than Ge, so the work done will be greater for the We because mgh work done is mgh and height is same, mass is same. Here the mass of sphere, the G is the only variable that will make the difference. So for higher G, more work done. For lower G, lower work done. That's simple. So you have to explain like everything, then you will get full marks. Then the next question is, a new pendulum is made by hanging the same small mass from different string with negligible mass. So string is now different string, underline it. A new string is slightly elastic. The length of the string may increase or decrease depending on the tension applied to the string. On Earth, when the sphere is again displaced theta from the vertical and released from rest, the new pendulum oscillates with time period Te. The new pendulum is taken to another planet, that is Y. The radius of planet Y is same as of Earth, but the mass of the planet is larger. So the mass of planet Y is greater than the mass of planet Earth. On planet Y, when the sphere is again displaced from the vertical and released from rest, the new pendulum oscillates with time ty. It is in a clear, coherent paragraph length response that may also contain drawing explain how ty could be larger than te but also could be smaller. So in this case, why there is no direct answer to it? That is because the time period of pendulum, if it is length is L and the gravitational pull is G, so the time period formula is root L by G. So now, if here we know that the G is equals to Gm by R square, so now R is the constant and mass is more for Y, it means that the gravitation for Y is greater than the gravitation than on the earth. So in that case, we will see that this gravitation, if gravitation will increase, the time period will decrease because it is inversely proportional. But if there will be more gravitation pull, if the gravitation pull will be more, this string will get more extension. There will be extension in the string. Due to the more length, the time period will be more because with more gravity time period will less, but with more gravity length will increase, and with higher length time will increase. So this doesn't clarify anything that whether the time will be more or less. So it could be larger or smaller. So these whole things you have to write in a beautiful manner and you will get the full marks. So that's it. Point B up to B, A and B, a very small question. Okay, then this is Akash and we did a question from AP Physics free response question 2024 fourth question. So if you have doubts, you can just put it into the comment section, and if you need any one-on-one classes, then you are welcomed here. Just message me and we'll start working on your physics. Thank you for being here.